Okay, good morning, everyone. Before today's lecture, I was just wondering if you guys have any questions about the unit, or about the particle questions, or about last week's lecture. Do you have any questions? Okay. Today, I'm going to talk about still C++. You know, some of you have already done C and C++, and you know there are some difference between C++ and Java and C#. And there are two major topics which are covered in C++, but not in Java, not in C#. And one of the topics is pointers, right? So in Java and C# use reference, but not pointers. Another one, of course, is dynamic memory management. Because in Java and C#, you got a garbage collector. So if an object is no longer referenced by any reference, any variable, then the garbage collector will claim them so that it can be reused by the system. But this is not the case for C++. So in C++, whenever you use dynamic memory, it's you or the programmer responsibility to retain or to reclaim or retain the dynamic memory back to the operating system. Otherwise, you got memory leaking problem, which is a very typical problem in C++. So today we got quite a few topics. So I can say most important, number one, pointers. Number two, dynamic memory management, which is the last one. And of course, there's one last topic, which is also very important because you probably need to use it in the first assignment, and also it's different from, from C# and Java. That is array. Okay, we're talking about how arrays in C++ are different from arrays in C#, arrays in Java. Okay, when we get there. Again, if you have any questions at any point, please feel free to ask me at any time, no problem. All right? The first topic I'm going to talk about today is about enumeration data type. You know, in C++, there are quite a few we call it built-in, or some people call it fundamental, some people call it basic data structures, or data types, not data structures, data types. For example, int, double, and so on and so forth. There are quite a few. So those data types has already been defined and come with the compiler. So you can directly, as a programmer of C++, you can directly use any of the data type, right? So for example, if you want to use a temporary variable I of integer type, all you need to do is you declare a variable that int I, and then you can use it in your program, right? So it's as easy as that. This we call the built-in or fundamental data types. But you can sometimes you probably need to define some new data types. There are quite a few ways to define and to introduce our new data types in C++ program. What I'm going to talk about today is just one of them, okay, which is called enumeration data type. All right? There are some other data types as well, but because of time limitation, I don't think I can cover all of them. Right? So what is enumeration data type, and how to define our new enumeration data type, and how to use our enumeration data type? So it's pretty simple. It's pretty easy. And this is the syntax. This is the syntax. So this is the keyword or reserved word used by C++. Enum stands for enumeration, of course, right? So this is the keyword followed by the new data type. This is the user-defined data type. All right, this is a new data type name. This is the name you pick up for that new data type. All right, and then followed by element list. Element list basically consists of a number of enumeration constants, which you will see in a few minutes. This is just an example. So for example, if in your program, you need to use, for example, direction, so which basically the value only for primary principal values. So one is north, east, south, and west. So how would you do that? Of course, you can always use an integer. For example, you use a 0 representing north, 1 east, 2 south, and 3 west. You can do that, no problem. You can definitely do that, right? But there is an alternative way. There is a better way to do that, which is to use enumeration data type. So if this is the case, so if you have to, for example, use direction in your program, in your C++ program, you should consider use enumeration data type. So all you need to do is you define a new data type by doing this. Enum followed by this is the name you pick up for this new data type. You can pick up your favorite favorite name, of course, right? And those are the values. Those are the values. For example, integer. If you have integer variable I, the value could be, for example, -1, 1, 5, and so on and so forth. So all the whole numbers are the possible values. Here, for this new data type direction, we enumerate all the possible values for this new data type variable. All right? So all possible values are enumerated over there. So there's only 4 values. So there are some advantages for doing that. For example, later on, if you declare a variable, the variable called heading, which is a direction data type, then heading's value must be one of the 4 values. So if you try to assign any other value to this variable heading, then the compiler, you will get a complaint from compiler program would not compile. So this is, which is good. You can check to make sure you will not send any invalid value to that variable, right? So this is the, we can do the, check the value, the type of the variables, right? So how the enumeration data types are implemented in C++? Actually, they use integers, right? They use integers. So for example, by default, so if you say, if you have, for example, direction, which has only 4 possible values, north, east, south, and west. So actually, in the internal implementation, they actually use integers. By default, if you don't do anything, by default, actually, north's the value is implemented, actually is encoded in, actually all the value included in integers. So the first one started by default, 0. So we use 0, represent north, 1 east, 2 south, and 3 west. All right, so actually this is the internal implementation, right? So there are some more examples. So for example, if in your C++ applications where you need to use some, for example, dollar notes, you can use like this. So the left-hand side we call enumeration constant. So there are enumeration constant. The value of the constant actually is 5. So we use an integer representation, right? So sometimes we don't have to always start from 0. So if we, sometimes we want to, for example, 5, there's a dollar note for 5, so we want to, use a value of integer 5. That makes more sense, right? More meaningful. right? So we can do that. So we can do that. We can assign each of the constant or integer value like this. So this is just another example for Roman numerals, right? So this is just another example. And so for example, if you are in your C++ program where you want to use, for example, months, or you build a calendar, for example, so you can use this way. So months, probably you don't want to start, first month you don't want to start with 0 from 0. So instead you want to use 1 the first month, second month, and so on and so forth. So basically this is equivalent to this. So this is so number one option is you create a new user-defined data type, which is this enumeration data type. So you have January, February, and so on and so forth. Right? So when in your program, they are very easy to read, right? Because when you use February, January, rather than use 0, 1, so this is the more meaningful, right? So this is the advantage using enumeration data type. But basically, this is equivalent to this. So you can declare 11 constant of integer type like this. Then there is a question, why would you bother? Actually, I have already mentioned some of the reasons. So of course, one of the reasons is using enumeration data make your program easier to read. That's the readability, can improve the readability of your program. And also, after the compiler translates your C++ program into the machine code, and sometimes you have to, for larger computer system, software system, you need to do some debugging, right? Then the debugging, so if you use a constant, when you do debugging, so you probably, for example, for months, the value could be, January, February to December, right? But then if you use a constant, integer constant, so when you do debugging, what you can see is just the 0, 1, 2, 3, 4, something like that. But if you use enumeration data type, then you can see, those enumeration constant, which are January, February, that's more meaningful, so much easier, right? This readability. Not just readability, this is also easier for debugging, right? So when debugging, you can still see the value of there rather than convert it into integers 1, 2, 3, 4, 5, right? Okay, so this is a couple of advantages, the reasons why we use. Of course, there are another reason which I have already mentioned that. So if you're trying to, if you use, for example, integer for direction, so basically we only need 4 values. So for example, let's say if we use an integer to represent a direction, then what happens, for example, if we assign integer 5 to our direction variable? If we use an integer, so that's perfectly fine, but it's not quite right because 5 probably is an invalid value, right? But if we use enumeration, which has only 4 possible values, so if you try to see any value, beyond that, then you will get a complaint from a compiler. So you can say immediately, there's something wrong with your program, right? So there are quite a few advantages. There is practical questions today, in this week's practical, I should say, because some people's workshop are scheduled for tomorrow. So there is a question, there is an exercise about the enumerating data type. In that one, you will be required to define a new enumeration data type, and then you use the enumeration data type in different functions, right? So there are quite a few. So what I'm going to do now is just to quickly show you some issues that you should pay more attention to when using enumeration data type, using this example. So as you can see, in this example, actually this is not a complete program, just program segments, right? You can see just some segments, program segments, some statements, that's it. So here we define, I should say, 2 enumeration data types. One is traffic light, color. So basically the value only 3 valid value. They are red, yellow, and green, right? And also define another one for gender. That's just male and female, right? And then we declare, so once we have defined or defined a new type, enumeration data type, then we can use it as a normal data type, a built-in data type. For example, we can declare a variable x, which is a traffic light color type. So this is the same. Integer I, the same. I is a type of integer variable. Here, x is a type of traffic light color, which now is a new data type, user-defined data type. And this is an integer I, right? So it's fine, okay? So this is probably some problem you may run into in this week's practical. So just pay a little bit more attention to this. So first of all, so for example, X is traffic light color data type. This data type has only 3 values. So those are the 3 values. So if you assign any of the 3 values to this variable, that's perfectly fine, right? This is something like I want to assign 1 to integer. That's perfectly fine, right? You can also assign, for example, X, which is a traffic light color type, to an integer, because as you know, why I mentioned the implementation, internal implementation of the, excuse me, of the of the data type. That's because internally there are all the constant, all the enumeration constant actually implemented actually encoded in integers. So that's why when you are assign, so basically these are integers, all right? So when you assign X, which basically is a traffic light color type, to I, which is an integer type, that's okay. So compiler would happy, but this is not a good practice. So you'd better to use this way. So if you sometimes, for example, if you define a dollar notes, for example, one of the dollars is 5, and the value is integer 5. Maybe you want, for some reason, you want to get the value, your 5. So you have how many notes of $5, how many $5 notes you want to get the total value, then you will need to get 5 and times by the number of the notes, which give the total amount of money, right? So you can use this way. You can use this way. You can assign this one to integer. This is perfectly fine. Actually, this is the good practice for the type conversion, right, from enumeration data type to integer data type. That's fine. And you can also do this. These are, I believe all of you should know, these are we call the typecast, right? So we transfer, convert from one data type to another typecasting, right? So this is that we do this. And this one is the same. So this is integer. This basically is an integer data type where this value, this X value can only be one of the 3. However, we can do the typecasting. We convert this one. So when you print out, so when you do this, actually X value should be green, right? Because by default it's 0, 1, 2. So 2 converted into traffic light data type, this X value would be green, the last value, all right? But you cannot do this. So for example, X is a traffic light data type where female is a constant value for another enumeration data type. So even all the enumeration data type are implemented in, basically encoded or implemented in integers. You cannot do this. You cannot assign female to X because female is a valid value for another enumeration data, which is a gender, right? You cannot do that, right? So you cannot do this either, right? This is a type you can directly put 5, over there. So you can't do that. Any questions about the enumeration data types before we move to next topic? Okay. Okay, what I'm going to talk about next is about pointers, which is a difficult topic in C++. For those of you who already done C++, and C, right? So this is pretty difficult. It's pretty much more complicated reference in Java and C#. Okay. So a pointer basically is a variable. So int I is a variable of integer type. Pointer is also a variable, but that variable is used rather than to store the value, like an integer, for example, I equals to 3. We store the integer variable, the integer value 3. Actually, the integer variable is used to store a memory location or memory address or address in the main memory. So as you know, all the program, if you run a program, the CPU can only access the data stored in main memory. So if your program is stored in a hard disk, for example, hard disk drive, you must load the program, the data, everything into the main memory before your program can access, can execute the program, can manipulate the data. So you have to load it into the main memory. So this is the common sense, right? So when you load, for example, a pointer variable in the main memory, right? So of course, the main memory, the operating system, will give a piece of memory which is used to store the memory address, not the value, but a memory address. Okay, I'll give an example to you very shortly. So before giving you an example, just to show you the grammar. So if you want to use a pointer in a C++ program, how would you do? Okay, so this is the syntax. This is the grammar. So this is the type followed by a star or a star and followed by this the pointer variable name. So it's a variable something like I. It's a but it's a pointer variable. Okay, this is just an example. So for example, if in your program where you want to use a pointer, and that pointer should pointing to a location in main memory where an integer is stored, then you should declare a variable p. So p is a pointer, or pointer variable, or or sometimes it's a pointer. It's a pointer pointed to a location where our integer, so this integer is stored. Okay, so if you want to use a pointer pointed to a double, then you would have to do double star p, or maybe p1. You can pick up any identifier, your favorite identifier. All right. So this is just some example. So for example, you can assign 0 to the pointer of any type. For this instance, the pointer type is an integer pointer, or pointed to an integer. All right. So you can assign to 0. Sometimes, for those of you who have already done C++ or C, sometimes a pointer is pointed to a location in the main memory, which doesn't make any sense. But if you want to manage to use a dereference, which I'll talk about in a minute, to get the value, you can still get the value. But this value probably doesn't make any sense at all. So it's not safe. So when pointer is not pointed to a meaningful location, so you'd better to use this one, either assign 0 or assign null, which is a constant to the pointer, which means currently the pointer is pointed to nowhere. It's not pointed to anywhere that is meaningful. All right. So in this way, we can avoid a lot of problems. And the last one, what's mean by this? For those of you who have already done C++, anybody can tell me what's mean by this? The last one. Do we have a yes?
Assigns to that memory location.
Yeah. So this one, this is a memory location this is the location in the main memory. This we call absolute address. This is the physical address in the main memory. So if you want to, it's pretty real for high-level program, C++ program to use this. But if we use C and C++ in embedded system, for example, I believe some of you probably are doing EN40, software engineering. So this would be terribly useful, right? So you need to get an address the physical address, and assign the address to the pointer. If this is the case, you have to do this type conversion, convert it into an integer pointer. Okay. Okay. This diagram just to show you number one. We're going to talk about a couple of operators defined on pointer. Okay. And number two, this is also show you, how the pointer type related to, how the pointer type is actually implemented. All right. So, for example, now we'll talk about the first one, which is we call the address operator. So this is address operator, which, as its name implies, this operator is used to get the address of a variable. Okay? So because in C++, as in other programming languages, when you do this, when you declare a variable I, initial value is 3, and the operating system associates this name, which is I integer variable name, associate this name with a particular location or address in the memory. So they are associated. Okay? So if we want to get the address of the variable I, then we can use this addressing operator. So this is how. Right? So P, of course, is a pointer of integer type, which means the value, let's say I's value, the location in the main memory, just an example, let's say it's 100. When we do this, we get the address of I and assign to pointer. So pointer is another memory which used to store the memory address. So the value, if you use the debugger tools in code view, for example, you can see the value here would be 100. So 100 is the address of this integer variable. Okay, so this is the get address of the variable. So for example, which is 100, then this would be 100. You will say in another address, this would be 100. So basically, so the pointer is pointed to the location where I's value is stored. All right, so this is a pointer. Any questions about address operator? Okay. Another important operator defined for pointer is we call it dereference. So dereference. So basically, this is a dereference operator. So this is also used for pointers, right? Pointer declaration. It depends on the context. So it depends on where this operator defined. If it in, for example, a declaration, then it means we are declare a pointer type. If it is used in, for example, in our assignment statement like this, that means they have different meaning. That's meaning dereference. What do you mean by dereference? Dereference means, just maybe I can use this example to demonstrate what's the meaning of dereference and how to use dereference operators in C++. So for example, initially, we declare 3 variables. Okay, one integer variable whose initial value is 3, and another integer variable, a second integer variable j, and the initial value is 5. So we can do them together in just one statement, one line. And the third one is a pointer. Which type of pointer? Integer pointer. So which means this pointer can only point it to a location where an integer is stored. If you point it to, for example, a location where a string or where a double is stored, that could be some mistake, right? So this is a little bit complicated issue. So we probably don't have time to talk about in very detail today anyway. So we'll talk about dereference operator first. So now we have three variables. We have basically two integers and one pointer, which is p. Okay, now we use the address operator. We get the address of I and assign the address of I to p. So initially, this is what the operating system has done. So initially, when you declare a variable of I type, or I of integer type, because you tell me, oh, I'm going to use a variable I, and the type is int. Then the operating system knows what's the size, how many bytes do we need to store one integer. So assuming it's 4, for example, it's 4 bytes for one integer. Then the operating system give the variable 4 bytes in the main memory. And then when we initialize 3, so we'll put a 3 here. So this is 4 bytes was used to store an integer 3 here. And also we'll associate I with this particular address. For example, 100, maybe 102, who knows, right? And similarly for J, we have a J associated with this memory, and we got the 4 bytes over there, which use, and also we use the 4 bytes to store integer value 5. And after have done this, we get the address of a variable I, for example, 100, assign 100 to this piece of memory. So which means this pointer is pointed to that location. All right? Okay, this is something that you already know. Now, this is a dereference operator. So what happens, for example, now we are using a pointer of integer type p. Now we want to get the value which is pointed, the integer value which is pointed by the pointer p. Okay, the value is pointed by the pointer p, which is 3. How we can get this value through or via this printer? These pointers are not printer. This pointer. So we use a dereference. The meaning of this, the dereference, the meaning of this is we get the value, the integer value pointed by the pointer, and return the value. We assign the value to j. So after we have done this assignment statement, then would become this. So this pointer pointed by this value, the value is 3. So the value of the right expression is 3. So we are assigning 3 to j. J was 5, now becomes 3. Okay. And we can use the pointer to access the value. Okay, the value pointed by the pointer. We can also the pointer to change the value pointed by the pointer. So this is how, for example, if we want to assign the value, we want to assign, if we do this, assign 9 to the location where it's pointed by p, then pointer pointed by p is pointed to I. So dereference, so we change the value from, actually we overwrite was 3, now it becomes 9. So this we call dereference. So 2 important operators defined for pointers. One is address operator, which is used to get the address of a variable. Another one is dereference, which is used to access the value pointed by a pointer. So this is an example. Any questions about the 2 operator, the pointer and the 2 operations defined on the pointer? Yes?
The syntax seems weird because in the second line, p equals like address I or whatever. You don't have the star before it, but every other time you use p as a pointer with the star before it.
Right. So you can say, that's a good question. You can say, so for example, if you use an integer type in the declaration, this is the type, this is the variable. If you want to use an integer pointer type, you can say this part is type. This is a variable. So that's why in the declaration, so this is the type. This is the variable, so you don't need to use this. I can use this. These are different meaning. So this means dereference. So you have to use PTR is the name of the variable. This is not a part of the variable. So this is the variable similar to I. So this is a data type, and this is pointer, integer pointer type for this variable. So that's why. Okay. Any other questions? Okay, now I got a question to challenge your guys. You got 2 minutes. Maybe after 2 minutes, if you have a volunteer, maybe you can tell me what's the solution, what's the answer to this question, and how did you get the answer, right? You got 2 minutes. So in this program, we use 2 integer pointers. They are P1 and P2. We also got 2 integer variables. They are I and J. So we get an address of I, and I'll assign the address to P1, and we'll get an address of a variable J, and assign that value, the address, which is of course a memory address, to P2. And this one, just to remind your guys, this is the dereference. Yes? Okay. You got it right. Okay, that's good. That's good. Are you guys finished or not? You finish it? Okay. Do you need more time? Okay. Right, and I probably, so basically there are 3 outputs over there. So this is the one. I'm probably get each of you to answer the question. So maybe you can tell me what's the output from this statement.
I didn't do like an output. I did like the drawing that you had before.
Or if you like, can come up to draw the diagram. Yeah, that's fine. Oh, don't worry. Yeah, that's not a problem. Yeah. Yeah, sure.
So this starts off with like P1 points to that, P2 points to that, right? Sorry? I'm sorry. Yeah. Okay. But it does that. Then P2 is 30, so it's those 30. And then P1 equals P2, so P1 is the reference to that. And then P1 equals 40, that's 40.
Okay, yeah. So what's the, sorry, I was not looking at your, so what's the output from the first statement here?
So count I would equal 30, right?
Do you agree?
For the first one? And then
The first one, yeah, the first one
and
here.
then space, then J would still be 20. Then space P1 would be pointing at I still? No. P1 would be pointing at I.
So what's the output from this one?
10.
10?
Yeah. Space P2, which is 30.
30.
Yeah.
Anybody got different answers? Yes.
Is it 1030, 1030?
1030, 1030, yeah.
Because I and the P1 is the same as I.
I did first.
Yeah.
Okay, it might be.
Yeah, okay, thank you.
Did I come to the right conclusion then?
Sorry, I didn't look at your. I'll probably draw again because I was checking his microphone to see it's working. Anyway, so I'll probably do it again so you can verify your result. So I can explain to you. All right, cool. Thank you. So initially, we have, let's say, we have I. We have another variable j. This is in the main memory. Can you guys see from the back?
Yes.
Okay. So I, the second statement, 10, and then 20, right? And then we have two pointers, P1 and P2. P1 and P2. And here, we get the address of I and assign to P1. So now, P1 pointed to this location. And similarly, P2 is pointed to this location after this, right? And this is a dereference operator. So we are assigned 30 to where? To the location pointed by P2. So 20 would be overwritten, right? So it becomes 30. So when we print out this one, the first output from here, we print I, the first I, 10, right? And white space J, 30. Are you happy with this? Okay. And then dereference. The value pointed by P1, value pointed by P1, 10. And then value pointed by P2 here, dereference. Value pointed by P2, 30. So this is the output from the first, from that statement. All right? Any questions? Okay. Because time limitation, I don't think we have more time to go through the rest of it, but I can show you the solution to this question very quickly. So basically, this is the output. So this is the output from that program. Okay? Any questions? Yes?
If you have an ampersand and then a variable, so the location of a variable, can you edit that with an equal sign? Can you assign something to that, or is it constant?
We get the address of a variable
Yeah.
and assign it to somewhere. Did you mean?
So can you assign something to it, or is it a constant?
You can send to a pointer.
Yeah.
No problem, as this one.
But can you do it the other way around? Can you change the memory location just by using equals?
No, you can't.
Okay.
No. Yes.
You can't use the brackets int star close brackets, then the memory location. You can assign memory using that, can't you? You said before.
You mean the typecasting? Did you say the typecast? You use a bracket, right? What you would put in the bracket?
I might be getting confused. Before you said you could point to memory location. P equals open brackets int star close brackets, then memory location.
So sorry, I'm not following you. So if you have a P, which we assume is a pointer of integer type, did you? No. Do you want to draw that?
What was your question?
If you've got ampersand P, can you say that equals something to change the memory location?
Like this, right? Like this. So the answer It's no, you can't do that. What was your question? Sorry.
No, it wasn't a question. I was trying to remember details when I didn't understand the question well enough. So don't worry.
Okay. Right. So this is about the basic pointer operations. Okay, just a couple of more slides before we take our 10 minutes break. We got 60 slides for today. Now I've got 40, so I got to be quick. Otherwise, I will not able to go through all the slides. So, okay, very quickly. Sometimes you may want to use a pointer. So basically, for example, if you define an integer pointer, double pointer, or maybe string pointer, that's perfectly fine. So if an integer pointer, that pointer can only point it to a location where an integer is stored. If you got a double pointer, the double pointer can only point it to a location in the main memory where a double value is stored. Then sometimes you want to, in your program, you don't know what's the type of the value beforehand. But you need to use a pointer. So how would you do that? So which means you need to use a pointer. It's a generic pointer which can point it to any data type. Okay? So if this is the case, you should use a pointer to void. Okay? How to use a pointer to void? So this is the syntax. Okay? You could declare a void, which is a keyword in C++. Void the pointer followed by the pointer variable or pointer in short. Okay, so this is the example. You can declare pointer. So this pointer v is a pointer which can point either to any data type. It can be pointed to an integer, a location where integer is stored. It can be v can be pointed to a location in the memory where double is stored. Any type, but sometimes it's very dangerous. Okay. I don't have time to explain why sometimes it's dangerous, but I give this question to your guys. Why using void pointer sometimes it's very dangerous? Can you work out an example to justify that? Okay, to explain why it's dangerous. I leave that one to you. Just one more slide before take a short break. Now. Here, so we use, for example, two integer pointers. There are P1, P2, and a double pointer, which is Q. Right? So Q can only point to a memory location where a double is stored. All right. And this is a void pointer, which means it can point it to any value, any type of value. Right. So. There are a few assignment statements on the left-hand side. All of them are good ones, are legal or good ones. So, for example, the pointer, you can always assign 0 to the pointer, which means currently P1 is not pointed to anywhere. Okay. Or you can assign this physical location, the physical address of the main memory, which is 1. To P1. So P1 is pointed to the location 1. So the value, if you use a debugger tool to look at the value of P1 at this stage, you can see the value is 1. Okay. And you can assign, because both P1 and P2 are the same pointer type, they are both integer pointers. Of course, you can assign P1 to P2 or the other way around, P2 to P1. So either way, both of them are fine. All right. And of course, V is a void pointer, or it's a generic pointer. So you can assign P1 to V, that's also fine, no problem. Or the other way around, maybe, for example, you can see V to P2. Right? I think this is V to P2, this is Q to V. So this is perfectly fine. 1 second. And also, of course, you can, so sometimes in some situation where you want to cast the pointer type from one type to another. For example, basically Q is defined as a pointer pointed to a location where a double is stored. But now we do the typecasting, so we cast this value into an integer. So this is an integer pointer. So after cast this one into integer pointer, we can assign to P1, which is an integer pointer. That's perfectly fine. Not perfect. This in terms of the syntax, is perfectly fine. But sometimes when you do that, there are some risk. So this is the question actually I've given to your guys, similar to the question. So why is dangerous sometimes? Can you work an example where this can cause some problems? Well, this is not good. All right. For example, if you assign Q, which is the double pointer, to an integer pointer, so without doing any typecasting, so this is not good. This program will not compile. Okay, it's similar with this one. You are assigning the physical address directly to this one without a typecasting like this. So this, you will also get a complaint from the compiler.
Sorry, if you already made void the v equal q, would you be able to do the p2 equals v, like put it throw up an error for that?
So you said again the void.
So if the void pointer is pointing towards double,
Okay, yeah.
will you still be able to make it equal, like make an int pointer equal void pointer?
So did you mean, for example, trying to clarify your question? So currently, the void pointer is pointed to a double,
Yeah.
and then
And then you're doing the p2 equals void, like p2 equals v. Would you be able to do that?
P2 equals to V.
So then that would make an int pointer to double, then throw up an error.
And for this one, it's safe to use this integer pointer, right? So it's safe to use typecasting, always use typecasting. Anybody, this actually raises a very important issue. Anybody can tell me, actually I was asking your guys to do that. But anybody can give me an example where, so we can, for example, we can assign a double pointer like this to an integer pointer, double pointer to our integer pointer. Where this is a double pointer to our integer pointer, right? By doing this, you can do that. But I said sometimes it's very dangerous. Why? Anybody can give me an explanation or give me an example? Yes.
If the number is too long and can't fit into the int, like size,
That's right. Actually, both of you get the point. The reason is, I show you. So, for example, I is an integer, right? It's an integer. So, assuming in this context, in this machine, we got 4 bytes for one integer, 4 bytes starting from here. Okay, because if you declare a variable I, which is an integer type, then the operating system will give you 4 bytes. Then if you declare another one, which is a double type, then the operating system will give you 8 bytes. And this is the address. This address, the starting address associated with K. And this starting address associated with I, so they are bounded, right? But this one, we got only 4 bytes, where for double, we get 8 bytes. So if we do the casting, now we have a pointer. Now, P1 is a pointer. Now, P1 is a pointer, the bottom one. We converted into, so initially, for example, let's say Q is a double pointer. This is a Q. Q is pointed to this position. Now we do this, the bottom one. We assign Q to P1, of course, using typecasting. Then P1 is also pointed to this location. Now they're pretty dangerous. So if we do this, for example, if we want to print it out using cout, dereference P1. Because P1 is an integer pointer type, which means the first 4 bytes are should be is supposed to be an integer. So when you print it out, actually they use the first 4 bytes to build an integer and output the integer value, which is wrong, right? Because here actually is a double. We use 8, but now we only use the first 4 bytes. We consider the first 4 bytes are the memory used to store a single integer. So you probably get a pretty shitty value. So that's why. Did you understand that? Okay. Let's take 10 minutes break. When you come back, we'll talk about more about proper pointer and arrays. Okay. There are quite a few slides left, so I'll go to be quick. Next topic is about references. So you know what I mean by reference because I already done, assuming you have already done Java or C# or or C++, whatever. So you have already know that. So basically, a reference is just another name for another, for a variable, right? So the basic idea, you already know that. So very quickly, my focus will be placed on what's the difference between reference and pointers, right? Because you will say there are a lot of similarities between references and pointers. So what's the difference between the two? So this is the focus of my presentation. So these are reference. So in C++, if you want to declare, if you want to program, if you want to use a reference, so this is the syntax. This is the syntax. So this is to declare a reference. The reference name is J. So if we put a star over there, that means it's a pointer. So if we use this is a reference. Okay. So this is a difference in terms of syntax. If in C++, whenever you use a reference, this is different from the reference in Java and C#. You must initialize, get the reference initialized immediately. If you don't do that, then you will get a complaint from compiler program would not compile. All right, so you have to do this. So what's the meaning by this? So for this one, if you just look at the top 2 statement, so you have integer variable I, initial value is 7. Now you got a reference J. Reference J, just another name for the reference I. Just another name for the reference I. So because it's just another name, so if you print out J, this is the syntax. You don't have, this is the syntax. If you print out J, 7 would be printed out on the screen. Why? Because J is just another name for I, where I's value is 7. So this 7 would be printed out. So if you do, you have already know this. This is a post-increment operator. So if you increment J, then both I and J's value are 8. What's 7 now 8? If you increment through the variable, this is through reference J, you change both value. Actually, there's only value stored. I will show you in next slides. So if you increment I's value using this, and both I and J's value, so for example, when you print out I and J, you will see both of them are 9. All right? So this is the one. This probably will confuse quite a few of you, particularly people who have already done Java and C#. So what's the difference? So basically, you have really understand this, right? So you have, for example, integer variable I. So in the main memory, you got a piece of memory, for example, 4 bytes to store the value of I, right? So I got this memory, and I is associated with this particular address. And then you declare a pointer. The pointer name is IPTR, and the initial value is the address of I, because we get the address of I, which is this, for example, 100, and put here. So this would be 100. If it is 200, then it would be 200. All right? So this probably makes perfect sense to your guys. Now I can tell you, okay, that's probably start confuse some of you. This is a reference. Reference basically is also used to store a memory location. So pointer is is a piece of memory used to store memory address. Reference the same. So for example, this reference of integer type. So this is a IREF is a reference of integer type. This, when you do this declaration in the operating system, they also give you a piece of memory which used to store the main memory address, which is basically the same. And when you do this, okay, pay more attention to the syntax, the different. Here we get the address of I and assign the address of I to this pointer. Here is different. The syntax is different. Here we're directing our assign, not get the address of I, but we are assigning I. So when we do this, we are assigning I to this reference. Basically, something that you cannot say is on the thing, all right? But what's happening is they get the address of I and assign the address back to the reference. So pretty much the same, but the syntax is different. Here you have to explicitly to get the address of I, where here is different. So the meaning of this assignment statement is different. The meaning of this is if the left-hand side is a reference and the right-hand side is a variable. So basically, they get the address of the variable and assign to this value. So it's pretty much the same, right? Then what is the difference? The difference is so when you, for the reference, for pointer, so if we want to get the value pointed by the pointer, you have to use a dereference operator, right? But for reference, you don't have to do that because the system to do that automatically for you. So from this point of time, so our reference basically is automatically dereference a pointer. What do you mean by that? I'll give you an example. Not here, the previous one. Oh, there's no example for this. Anyway, so okay, I'll probably work out another example for you. So I just quickly explain this. So basically, when you use a dereference, with a pointer, so you have to use a dereference. If you want to get the value pointed by a pointer, you have to use a dereference operator explicitly. Well, if you want to get the value pointed by a reference, you don't have to use a dereference value. So for example, IREF is a integer reference type. If you want to get the value pointed by that reference, I'll probably still use this one. If you want to get the reference pointed by this, you can, for example, if you want to print it out the value pointed by this pointer, you would have to use something like this, right? You have to use cout dereference. The pointer name is IPTR. You have to use this. Dereference explicitly. Well, the same problem, if you want to print it out the value pointed by reference IREF, you don't have to use dereference. So instead, you can directly use this. You don't need to use a dereference. Why? Because the system do the dereference automatically for you. So this is what I'm trying to say here. So this would point it out the value pointed by reference IREF, right? So this is the one. And also, our reference must be initialized. So when you declare a reference, you must get initialized immediately. Otherwise, the program would not compile. So it's something like this. So for example, here, so when we declare a reference R, we need to get initialized immediately. For example, we assign an integer variable x immediately to the reference. Okay, you have to do this. Otherwise, the program would not compile. And the third difference is pointer is something like a variable. Okay, so for example, you can initially have a pointer P1, initially pointed to one location where an integer is stored. Later on, you change the pointer P1 so that it pointed to another location where another integer is stored. Right? That's perfectly fine because it's a variable. But a reference is different. Reference is something like it's also something like a pointer. Why? In a sense that it's pointed to a location, right? But it's not a variable because once the reference is associated with our, is pointed to one location, you cannot change it afterwards. You cannot make any change. So if you're trying to, for example, trying to do this, initially it's pointed to location where X is stored, and now you're trying to change the location to pointed to or store location where Y is stored. This would not compile. This will result an error. So this program is not good. All right, you cannot change it. So it's something like a constant pointer, right? So it's pointed to somewhere, but you cannot change the value so that it pointed to another location afterwards. You can't do that. So those are the difference between references and the pointers in C++. Okay. Any questions? So why I introduced this concept? Normally people, when I talk about C++, some people talking about the reference, some people rather not talking about that because probably confuse quite a few guys. The reason why I want to introduce this concept, because I think it's number one, very important. Number two, this is essential for me when I introduce the concept of call by reference in a few minutes' time. Yes?
What if you just wanted to reference the value of y? Say, the value of y.
The value of y. Using reference or use a pointer?
As a reference.
As a reference, then you would have to do this in the first place. For example, int reference r equals to y. You can do that. But once r pointed to y, never change in the rest of your program. You can never change in the program because something like a constant. Yeah.
I mean, like, if you reassign it to x, let's say x is 5, y is 10, we will make x equal to y. And can you do that through
X equals, when you do x equals to y, you only copy y's value to x value. It does not change the reference. Did you understand?
So it just changes the value of x.
That's right. It does not change the address. So R is still pointed to X. You cannot not able to change it so that it pointed to Y. You can't do that. Because you can say, logically you can say, this is a constant pointer. The value cannot change. It is a pointer in a sense that it stores the address of a main memory. But the value, the address never change. It always pointed to the same location. That's for reference. A pointer is different. It's a variable. You can change it, from time to time. Okay. Okay. Now, next topic, important topic, which I believe you are using in today's practical. So about arrays. Again, So I'm not going to, because of time limitation, I'm not going to spend much time talking about what's meant by array, because all of you, I believe, know what's the concept of array. So my concentration will be placed on the difference between the array and the array in C++ and the array in Java and the array in C#, right? Anybody can tell me what's the major difference between arrays in C++ and in C and the array in, let's say, C#? Anybody can tell me? Just one quick point. Yes?
Isn't an array essentially just a pointer?
Yes, but this is not the major difference. This is not the one I'm looking for. Yes, you're right. It's a pointer, basically. I will talk about that in a few minutes' time. Yes.
Can you add constants like information to the array without having to change the size of it?
That's a vector. That's a different one. It's another data structure. Yeah, we're talking about that. Anybody can tell me any new ideas? Okay. The major difference is in C# and in Java, array is a class, right? So whenever you use an array, you create an object of array class. Is that right? Okay. But in C# in C++ it's different. In C++ and in C, they are fundamental data types. They are not object of array classes. There is no array class whatsoever in C++. All right? So there are a lot of consequences, there are a lot of difference result from that. So for example, because in Java and in C# array is a class, so basically it's a class type. So in the class, there are some class variables, and one of the class variables is the number of elements in the array, right? So if you want to know how many elements in the array, you can, get or use a function, something like that, immediately get the size of the array. But in C++, array is a fundamental data type. So there is no such a class of variable. There is no any variable where the size of the array is stored. Okay, then how could we deal with the problem? So this is something that you should concentrate and look at, all right? So this is array. So this array, for example, so basically array is used to store sequence or number of elements, data elements of the same data type, right? Different data type use a different data structure, right? The same data type. So this is just an example. So for example, if we have array which use array of integer type, so in the main memory we have 5 consecutive memories used to store the 5 integer elements in the array. Syntax, this is the syntax. This is the type, the element, the type of the element in the array. This is array name followed by the length, how many elements, or the capacity, the size of the array. All right, this is an example. So for example, if we want to use an integer array, a one-dimensional array, so this is the name of the array name. This is the one you pick up. This is the type of elements in the array. So which means in this array full, there are how many? 5 up to, you can store up to 5 integers. So this is the element of data type integers. So this is how, right? And array initialization in C++, this is initialization. So declaration, so you want to use an array of 5 elements. So with initialization, this is an initializer. So this is the value, the 5 initial value of the data element in that array. So this is the situation in the main memory. You would look like like this. Array in C++, as in Java and C# will start from index 0. So the index 0 is 9. Index 1, 7, and so on and so forth. Right? So if we do this, so the size of the array or the length of the array is 5. However, if you look at the initializer, there are only 3 elements, 3 integers in the initializer. This is fine in C++. If this happens for the rest two, so the remaining two, the first three, we use this one to initialize. For the rest two, we use the default value. Because the element data type is integer, so the default type is 0. So this is the situation after the initialization. It's pretty straightforward. Okay. Sometimes you don't have to specify the names. You can get the initializer to determine the size of the array. So for example, if that open, this one only takes 3 elements, so the size would be 3, like this. How to access the element in the array? Of course, all the elements in the array can be accessed by index, right? So you can use the index number. So for example, very quickly, so you can get the first element in the array and assign to because the element type is integer, assign to an integer variable x, or you can assign it to the second element in the integer array, and so on and so forth. So this is an example demonstrate how to use C++ arrays. Okay, it's a very simple program. So in this program, we use a constant n. So constant n. So this is the value is 5. This is a constant. Okay, n value is 5. So here, so basically, we have the core part of this program has 3 for loops. The first for loop basically is to fill the number. For example, the iterate, because n is 5, this would be iterate 5 times. And in the first iteration, when I equals to 0, 7 plus 0 times 0 gives 7. So A0 equals 7. Second iteration, when I equals to 1, 7 plus 1 times 1 gives 8. So A1 equals to 8, and so on and so forth, right? So this is just to fill the array. And the second one is easier to understand. Basically, we're printing out the data members in this array, in this order. So from the first one to the last one, this is the one. And the third for loop used to calculate the sum of the data members in this array. So that would be 7 plus 8 plus blah, blah, blah. So you print the reason. So this is pretty simple, right? Any questions about this? Should be straightforward. Okay. So the result output would be here. The output would be this, okay, from the program. Anyway. Okay, this is a very quick one. I'll probably, because of time, I don't want to get your guys on the question. So instead, I'll probably quickly explain to you because they're very straightforward, very easy. So this is the some questions related to array declaration and initialization. So something wrong with the first one. Why? Because this length is 4, but the initializers contains 5 integers. So this is the something wrong here. This program will not compile. All right. And this one is case sensitive, so it's not a capital I. So you have to change into small letter I. Where for this one, so because one, the integer type is missing, so otherwise, other than that, is 5. All right, so very quickly go through this one. Okay, now we already know arrays. So of course, limited to one-dimensional array at this point of time. We already know what we mean by pointers. Then what I'm talking about right now is, what's the relationship between the pointers and the arrays. Okay, so that after that, so you have a better understanding of arrays and also pointers. All right. Basically, the array name. So for example, we declare array integer array. Foo, for example, foo is the name of the array. Foo actually is a pointer. Foo, the array name basically is a pointer. Okay, basically it's an address. Of course, it's always pointed to the same location. It can never change. It's something like a constant pointer. always pointed to the same location. So array name is a pointer. It's a constant pointer. Always pointed to the same location, never change. Okay? So because array's name is a pointer, so we can do this. So for example, we have here, for example, we define we use a constant capital N. The value is 100. So the constant, we define a constant. We declare an array. So array name is A. A basically is a pointer. It's a constant pointer. And the length of the array is 100. So we have another 3 variables. This is the sum, the total sum. And this is the assumption we made. We have also declared another variable of integer type I. We have an integer pointer P. Okay, P is an integer pointer. So now, this statement is equivalent to this statement. So you can assign A, which is our array name, to our pointer. Of course, has to be same type. So P is an integer pointer. All right. A is an integer array's name. So you can assign A to P. After doing that, P is pointed to the first element in the array. Okay. So if you want to move the pointer so that it's pointed to the second element in the array, that's what you need to do is use this array operation. A pointer operation. So A, that's the address, plus 1. 1 does not mean 1 byte. 1 means 1 unit location. For example, for this one, because the data type, the element type of the array is an integer, which means 4 bytes. So let's say if A is the pointer pointed to the first element, then if we, assuming the first address, the first element's address is 100, then actually when you A plus 4, the actual address value is 104 because of 4 bytes. All right. If the element type is double, when we do this A plus 1, actually it would be 108, assuming the first element is 100. So plus 1, that's 108. Okay, so this is the operation. So this is just the equivalent. For example, we get to the first element of the array, get to the address of first element and assign to P, and get the second element, the address and assign to P. So these are equivalent. Those are equivalent. Okay. Have any questions?
Would you recommend the right hand of the and column as more correct?
No, actually you can use it either way. This is up to you. So it's hard to say which one is better than the other. Yeah, doesn't matter, whatever you use. Right? Okay. So and also those two program segments doing the same thing, so they are equivalent, right? So basically, one is directly use the index of array to access the element in the array. So basically, what the segment does is to calculate the sum of the element in the array, right? Starting, so initially 0, the first is breaking it up, the first element to sum, the second is add the second element into sum, and so on and so forth, right? So the same. But the first one is directly use the index to access the element in the array, where the second one is different. We use a pointer to access the element in the array. Same thing, right? But this looks pretty more straightforward for most of you guys, right? But some people prefer using this, which is also fine, no problem. Okay. So, as I mentioned, array is array name basically is a constant pointer. So you cannot do this. So for example, assuming we got two arrays, let's say both of arrays A, we got array A, array B, both of them are integer type. You cannot do this. For example, you assign B to A, you cannot do that. In C# and Java, you can do that, right? It's basically just another reference pointed to the same array object. Here it's different, you can't do that. Okay, you cannot do this either. For example, you change the array's pointer, advance the pointer to the next position. You can't do that. Why? Because it's a constant pointer. Because a constant, you can't change its value. All right. So this is the difference between or the relationship between the pointers and arrays. Okay. Now, very quick question about array and the pointers. So this probably I just give the answer to you guys because of time nature. All right. So basically, this is as you can see this here. What's this? This is a function which you take one parameter. What type of the parameter? Reference. Okay, there's a reference. We copy it. There's a reference here. So the question is, which of them are the acceptable function calls? So, which of them are function? So this is a good one, right? Because this is basically it's an integer reference type. So this is an integer reference type, and this is also an integer reference type, or not? That's right. So only 0, 1, 2. So this is not a good one. What about this one? That's equivalent to A2, so which is fine, right? So this one is good. What about this one? A is a pointer, is a reference type, so this is not good, right? What about this one? That's fine, because this is a number, this is an integer type. Okay? Okay, now, yes?
I was just wondering with that last slide, because the number isn't in the square brackets that the arrays are.
The number, you mean this one, the bottom one, right? So this is equivalent to do this. So when we have a function declaration, we have defined a function. Now we are using, this is basically a function call. We make a call type function. When we do this, we need to copy. We are talking even more about that. We copy the argument to the corresponding parameters. All right? So this is equivalent to this. Right? Which is fine. So this is an integer, right? This is just give another name for this integer. So this is a copy, this one. Actually, it copy the address. It's not the copy the value, but the address of this to that one. So this, if you look at this one, this assignment statement is perfectly fine, right? So whenever we make a code, we do this. We copy the corresponding argument, to the corresponding parameters, right? So this is fine. So that's not a problem. Okay, so I'm not sure I answered the question or not. So what's what? Okay, good. Copy arrays. In C++, you cannot directly, use, there is no aggregation operation for array copy, which means you cannot copy a whole array to another array. Cannot do that. So if you want to make a copy of the array, this is different from, again, this is another difference from arrays in Java and C#, right? So array C# basically are objects, so you can make a copy. You can easily make a copy of objects, right? This is it doesn't matter, it's a shallow copy or deep copy. But anyway, you can make a copy. You use a single operation, but this is not the case in C++. In C++, if you want to make a copy, you have to do this. You have to copy the elements like this. You have to do this. So you have one array, you have to declare another array, array 1, array 2. If you want to make a copy, you have copy the element in the array 1 by 1. All right, so just pay a little more attention to this. It's different. You can't simply assign array 2 to array 1 to array 2. You can't do that. Actually, it wouldn't work. Right? Why it wouldn't work? Because array's name basically is a constant pointer. You assign one constant pointer to another constant pointer. You're trying to change your constant pointer. That's the result of a grammar mistake, grammar error. Okay, now very quickly talk about call by value and call by reference. Very quickly, of course. Call by value, so you have a function which takes some parameters. Okay, this is terminology that I use in this presentation. So when you define our function in the function prototype, we take some parameters. When you make a call to that function, sometimes you need to pass some argument to the parameters, right? Depending on the type of the parameter, sometimes we pass by value, we pass the value, we make a copy of the value. Sometimes we copy the address to the parameters. So that's why we have two different, parameter passing. One is called call by value, another one is by call by reference. Call by value is pretty straightforward, right? So just to give you a very quick example. So this is the call by value. So here we have a function called bin, which takes two parameters. Both of them are integer type. So when we make a call to that, we pass this is a function call. We pass two arguments, I and j. Here, if this is the case, because they are integer type, so we copy the value. So we copy the value of j to the corresponding parameter, which is a. We copy the value of k to the corresponding value of b. So after the function call, this will not affect, for example, j and k, because so something we change. We already make a true copy. So everything you change inside of function call would not affect the variables, the arguments outside of the function, right? So I don't have too much time to explain this, but anyway, this should. I believe you guys should be very happy with the call by value, but sometimes you may have some difficulties understanding call by reference. Okay, that's why I skipped this one very quickly. I probably also skip this one either. Now, talking about next topic, which is call by reference. Call by reference, we make a call rather than make a copy of the value. Get a copy of the value and assign to the corresponding parameter. We actually pass the address of the argument to the parameters. Not make a copy of value, but make a copy of the address. That the result would be different, as you can see. Okay, now it's a little bit more complicated in C++ than in other programming languages, because when we talk about the copy address, there are two ways to copy address, to pass address into a function call. One is we use pointers, so that's the one over there. Another one that I will show you in a minute time is a reference type. So that's why I introduced the reference concept. Okay, here, so you can see here, this is a function prototype. So this is swap, take two parameters. Both of them are integer pointer type, right? So initially, we got two variables, both of integer type A and B. So A's value is 3 and B's value is 7. When we make a call, okay, pay more attention to the grammar. So when we make a call, because this requires, this is a pointer, so which means you need to get to the address. Okay, so when we get to the address, this is equivalent to this. For example, the first parameter is integer type. Integer pointer type. P, integer pointer, P equals to get address of A, right? So this is perfectly fine. Get the address of integer A and pass it to pointer, right? This is fine, no problem. So anything, so because you pass the, I probably draw, this is very important, because I probably draw a very quick diagram for you guys. So we have A, 3, value initial value 3, we have a b. Initial value is 7. Okay? And in the function, swap in the function, so the two parameters, something like a local parameter. Okay? This is something like a declaration of a local parameter. So you have two local parameters. We have p. P is a pointer, integer pointer type, right? And then we have q. Is that q? Yes. Q also integer pointer type. So when we make a call, this is a function invocation, we make a call. Basically, what we do is here. So this side is that side. Integer pointer p equals to this one. We'll get the address of A, get the address of A assigned to this. So as a result, p is pointed to this location. Similarly, after this one, the second parameter, after done this, q is pointed to this location, right? So see, we pass the address of A to P, address of B to Q, not the value, not to make a copy of the value, but actually we pass the address. We get the address of A, we get the address of B. So inside of this, we have another temporary variable. This temporary variable called TMP. Initially, does not hold anything, does not have any number. And then dereference. This is what? The value pointed by P to temporary. Value pointed by P, 3, put temporary variable. And then here, we are assigned the value pointed by Q to the value pointed by P. Pointed by Q by P, here, 7. Okay. And then next one, temporary are assigned to the location pointed by Q. Location pointed by Q, temporary value, 3. So see, they are swapped. All right? So this is what we mean by call by reference. This is one example. There's another example. In this example, we use a pointer implementation. See, because the two parameters are both pointer type, integer pointer type. So this is another one. So if we look at the skeleton, pretty much the same. The only difference is, instead of using pointers, we use references. Two reference, integer reference P, integer reference Q. And therefore, the grammar are different, because for dereference, if we use a reference, the dereference is done automatically. So when we make, for example, when we make a call, if we use a pointer, we have to do this. We get the address of A, get the address of B, and assign it to the corresponding pointers. But if we use a reference, so this is the syntax. Right? Why is that? Did you remember? The dereference is just another name, right? So initially, for example, this is just another name for A, right? Looks pretty familiar, right? So this is what this syntax. This is different. Okay. Anyway, quickly move to last topic. I probably have to leave this question to your guys, so I would suggest you try out these questions. Very quickly talk about what I've done more about the array. So what I have introduced so far is just a one-dimensional array, but sometimes you would have to use a two-dimensional array or multiple-dimensional arrays. So this is a motivation example. So for example, when you're doing a develop a system where you want to, for example, store this information, this the score for one class of students for different subjects, right? So this column are the student numbers, for example. So each column, this second column is the score for the test 1, test 2, and so on and so forth. So if this is the case, you would have to use, for example, two-dimensional arrays. So this example, this is how, for example, the value is double, so this is the how to do that very quickly. In C++, multiple or two-dimensional or multiple-dimensional arrays, basically, for example, for two-dimensional array, basically it's an array of arrays. Okay, why is that? So, for example, the one dimension is an array. This is the first one. This first dimension, 0 to 29, so 30, right? And for each of them, each of the row is also another array. So just see if we look at the horizontally, so this is another array. So array of arrays. This is how C++ array implemented. Okay, this just to give your idea how the arrays actually stored inside of the main memory. So for example, this one, so starting from one location. So the first one, if you refer back to the table, right? The first row, second row, third row, and the last row. When we store the element for one row in the table, in the original table, we start from left-hand side to right-hand side. Okay, this is how. And also, for example, if B is a pointer pointed to the first location for the array, then the second location would be B plus 8. Why is 8? Because the type of element is double, which occupy 8 bytes. That's why we every time increase by. Okay, very quickly, the two-dimensional. I have to leave this one to you. So this is declaration and initialization for two-dimensional and multi-dimensional arrays. So there is an example demonstrate how to declare and use two-dimensional and multiple-dimensional arrays. And also I have to leave this one to you as well. Is a string. In C++, there are two types of strings. One is we call a C-style string. Another one is object. It uses a class object. What I'm talking about in this slide is C-style string. What do you mean by C-style string? C-style string, a string is considered as an array of characters. This is a C-style string. Another is a C++ style string. This is basically an object of string class, which I'm talking about later, not today. Finally, there's another one, too many contents. So basically, this content are supposed to be covered in 2 weeks lecture, but I put them together in just 1 week. So that's why we got okay, so this can be considered as an application for the arrays. So in the main function, actually take 2 parameters. The first parameter is the total of the arguments. Okay, and the second one is actually the argument's name, which is the type of strings. So each name is a C-style string. That's why I would like to introduce a C-style string. Otherwise, if you directly use C++ style string, probably you would not able to understand this. Okay, I have to leave this one to you. Finally, actually, this is a very important topic, but this is not completely new to your guys. This is about dynamic memory management, which I talk about more. I just quickly go through. So you will use new when you create an object. For example, you can use a dynamic array. So there's a dynamic array example over here. So for example, when you no longer need a dynamic object, you have to manage it. So it's your responsibility to manage the dynamic array. So you can delete. When you say delete, you just return the space occupied used by the dynamic objects back to the operating system so that they can be used by other applications, something like that. So I have to shut up now. Otherwise, no. I would suggest you guys, go through very quickly. Maybe in the beginning of next week's lecture, I will spend some time talking about dynamic memory management because it's very, very important. All right. Okay, thank you. I don't think I have time to take questions today. See ya.